Hey guys, welcome to the third tutorial in Python. In today's video, we're going to discuss what is classification and what is regression. So let's get straight into it. Last video, we left supervised learning standing at a diversion. Is the thing you're predicting a number or a category like not spam or spam? Now, it almost sounds quite trivial, but it actually isn't. That single choice changes the geometry your model draws, the math it uses, and even the words we use for explaining it. So let's take two real problems that look like twins. Predicting a house's price and deciding whether an email is spam. And let's see these things split into two completely different shapes the moment we look at their answers. Now, let's look at only the outputs. When we judge the price of a new house using a ML model, a price lives on a continuous number line, 800,000, 800,001, and anything in between is meaningful. It slides and it has infinite options. But spam or not spam has exactly two options. Either the email is spam or the email is not spam, with nothing valid in the middle. There's no such thing as a 0.3 spam or a little bit spam, and there's nothing like that. You either jump from spam or not spam. That's a real dividing line in supervised learning, and it has nothing to do with the inputs. Both problems might use the same house or the same email, but it's entirely about the shape of the output space, whether it is a continuous line or a discrete set of buckets. Continuous output, which we call regression, which is our numbers, and discrete output, which is spam or not spam, which is called as classification. Now, what exactly is regression? When the output slides from example 800,000 to 800,010, the model becomes a curve laid through the data, and predicting it is just reading the height of that curve. We're devoting the entire next video to exactly this. So I'll keep it to one line here. Regression answers how much, and its geometry is the height of a curve or the line. Now let's see what is classification. Now, when the output jumps from, let's say, spam to not spam, the model does not draw heights, but it starts drawing borders. Everything on one side gets called as one class, and everything on the other side the other. To classify something new, you don't need to find a new value. You just ask which side of the border it is part of. And here is the subtly most explanation skip. Good classifiers usually don't hand you a hard spam or not spam directly. They first produce a probability. I'm 92% sure that this is spam, and then only convert it into a decision by comparing it to a threshold. Like, for example, if it crosses 70%, then we know it's spam. And that's powerful because the threshold is a dial you control. Raise it and you only flag emails you're very sure about. And when there are more than two classes, let's say recognizing a digit from 0 to 9, the same idea generalizes. The model outputs a probability for each class and picks the highest, and it also should qualify with the threshold. Now, here's a question worth sitting with. If regression is so simple, why not just use it for classification? Label spam as 1 and not spam as 0. Fit a straight line and call anything above 1/2 spam, and we're gonna call it as spam. Now, if we try it, it's obviously gonna break because the line doesn't stop at 0 and 1. If we push the inputs far enough, it can predict 1.4 or negative 0.3 because lines are absolutely infinite. Values that are meaningless as how spam this is. Worse, a single far-off example can tilt the whole line and drag the boundary to a terrible place. So we need a function shaped differently, one that gently squashes any input into a range 0 to 1, so the output always reads as a clean probability. That S-shaped squashing function is the entire idea behind logistic regression. Even though its name is logistic regression, it's actually a classification method. One last thing that makes the split feel real is that, remember the loss from last video? The single number a model tries to shrink. Regression and classification don't even use the same loss. Regression measures wrongness by how far the number is, which is called as the square error. And classification measures it by how confidently wrong the probability was, a quantity called as cross entropy, which barely punishes a cautious mistake but punishes a confident wrong, I'm 99% sure, enormously. Different outputs, different geometries, and different losses for both regression and classification. So, whenever a new problem lands on your desk, you only ever have to ask one question first. Is the answer a number or a category? And that one question decides everything, whether it's regression or whether it's classification. If this video helped you understand what is classification and what is regression and the difference between both of them, then make sure to subscribe and hit the like button for more videos like this.